Hello everyone, welcome to another Python tutorial series. In this video, I'm going to talk about the Ursina Engine, setting up a target that is bound to be hit. So in this video, I'm going to show you how to set up a target in your Ursina Engine, so that no matter where a fireball comes from, it will always hit the target. So first, let's import the modules that we're going to be using, and we're going to be writing this in Python. Now to import our modules, we can just type in import star because we're going to be using the Ursina module. And let's also create two entities, one as the background and the other one as the target. But before we do that, we also want to import the math module because we're going to be using that as well, and random. So from random, import rand int. So we're going to be using the random module as well. Now to set up our basic app, we could type in app is equal to Ursina and then app.run. And here we just set up the app. And now to create our background, I'm going to create an entity. I'm going to set the model equal to a quad. Set the scale equal to 2010. And I'm also going to set the texture equal to an image in my assets folder called blue sky. Now I'm also going to create a target entity, so that's another entity as a quad. I'm going to set the z to -0.01, that's the z position, and set the texture equal to an image in my assets folder called target.png. And if I save and run this, let's see, app is equal to Ursina from Ursina import star. You spell this right. And now when we run this, we have a nice background and we have a target in the center. So now we want to basically spawn fireballs from out of the screen in order to actually hit the target. And in order to do this, we need to create a fireball class, a fireball entity class. And so I'm going to create the class up at the top. So class fireball of entity. I'm going to define init of self and angle. I'm going to call super.init. I'm going to set self.parent equal to camera.ui. Self.model equal to quad. I'm going to set the texture equal to a fireball image, so fireball.png. I'm going to set the angle equal to the angle, which I have as a parameter, and set the scale to a random integer from 4 to 8, and then I'm going to divide this by 100. Now I'm going to set the distance equal to 0.8, and this is going to be the initial distance that the ball is away from the target. Set the position equal to self.distance multiplied by math.cosine, and here we're using the math module. Self.angle, the cosine of self.angle divided by 180 multiplied by math.pi. And that's the x. Now for the y, it's going to be self.distance multiplied by math.sine, and the sine of the angle multiplied or divided by 180 multiplied by math.pi. Now I can also set the speed. So self.speed equal to rand int 2 to 5, and then divide that by 1000. And change in x equal to the negative math.cosine self.angle divided by 180 multiplied by math.pi multiplied by self.speed. And this is going to be the initial speed in the x direction. Now we can also set self.change in y is equal to the negative math.sine of self.angle divided by 180 multiplied by math.pi. And then again multiplied by self.speed. So we can also add in an update function to move the fireballs and do some boundary checking. So I'm going to add in an update function. So define update of self. And I'm going to set the position. I'm going to increase the position by the change in x and the change in y. So self.x plus equal to self.dx and self.y plus equal to self.change in y. And I want to check, or I want to add in some boundary checking. So if the square root of self.x squared, self.x squared plus self.y squared is, if this is greater than self.distance, then we'll set self.angle equal to rand int 0, 359, and so anywhere from 0 to 359 degrees. Self.scale equal to rand int 4, 8, 100, so choose a number from 4 to 8, and then you divide that by 100. We set the speed equal to rand int 2 to 5, divide by 1000, and we'll set the position equal to self.distance multiplied by the cosine of self.angle divided by 180 multiplied by math.pi, and then self.distance multiplied by math.sine of self.angle divided by 180 multiplied by math.pi. And then we also want to add in self.change in x is equal to the negative math.cosine self.angle. Actually, we could just do this. So it's equal to copy and paste from the init and paste it right here. So that change in x is equal to negative math.cosine self.angle divided by 180 times math.pi times self.speed, and the same thing with change in y, except it's going to be sine. And now we want to create 5 fireball entities. And so in our main, we can have a num variable, which represents the number of entities we want. And then a fireball is equal to, and this is going to be an empty list so far. So for I in range num, in this case 10 times, we're going to create a fireball object of the fireball class. And we're going to add in a parameter, which is going to be rand int from 0 to 359. So if I save and run this, I have a bunch of fireballs, which is just 10, and you see they're all spawning and going towards this target. I'll let this play a little longer. If I close this and change this number to, let's say, 30, now there are a lot more because I increased the number of entities that we have. And there are, of course, many applications for this kind of targeting element. But this is the end of this video. Thank you for watching, and I will see you guys next time.